Okay, welcome back. Just last thing I wanted to mention here. So right now, these are our two solutions. X equals negative 13 over 6 and x equals 3. Going back to the graph I just did, these are the same x values as these points right here. So x equals 3. If you do negative 13 over 6, you should get this decimal on your calculator. So again, this just shows that the method that we did actually works. So my method here was to bring everything over to one side of the equation that was equal to 0 on the other side, and then find the zeros of that new equation. So once we have that, that will solve our equation every time. Now, some potential issues pop up. What if it doesn't factor? Well, then we have other ways of going about it. And of course, vertex form is a little bit different, that there's already one x in the equation, so you can just solve for x there. But in general, with quadratic equations, everything over to one side, 0 on the other, and find the zeros. Okay, whenever it says solve an equation, that is what you're going to be trying to do if it's a quadratic. Okay, let's try a couple of others. So now let's take a look at one that's inside vertex form. So I'm given y equals negative 7 bracket x minus 4 all squared plus 13, and I want to solve y equals negative 8. So I'm going to do that, put in y equals negative 8, and it says solve. So solve means solve for the unknown, solve the equations. The unknown here is x. Now, I could, again, bring everything over to one side of the equation, like I did with the other ones, but this is vertex form. And with vertex form, again, only one x, that one right there, we should be able to rearrange the equation and solve for x. That is true anytime you have an equation with only one x. So what I'm going to do here first is I'm first going to subtract 13 from both sides of the equation. Oops, excuse me. Minus 13. So negative 8 minus 13 is negative 21. Okay, and you can try and finish the rest on your own here, but you're just going to divide both sides here by negative 7. So negative 21 over negative 7 gives you 3. Okay, and now I can take the square root. So I'm going to get plus or minus the square root of 3 on the left side, x minus 4 on the right side. So x will be equal to plus or minus root 3 plus 4. Okay, so x is equal to root 3 plus 4, or x is equal to negative root 3 plus 4. Both of these are possible answers. Okay, and again, so I didn't have to do any factoring there. I was just able to rearrange the equation and solve for x. That is the nice thing about vertex form. And even if we learn other methods later on of solving these types of equations, with vertex form, it is always faster to solve for x just by rearranging the equation. Okay, let's take a look at a couple of others here. Here's a whole bunch of other equations we can look at. I'll do a couple with you and then let you try the rest on your own. So first off, b squared minus 10b equals 0. If you think about our general goal being to get everything over on one side of the equal sign, 0 on the other, it's not vertex form here, so that's going to be our goal. So this is what we have. Now all we need to do is factor. This one factors relatively quickly. We're just looking for our greatest common factor here between b squared and 10b. Common factor is b, and you're left with b minus 10 left over. Okay, so what are my answers going to be? Well, I have my two factors here. So this means that either b equals 0, that gives me one answer, or b minus 10 equals 0, which tells me that b equals 10. So I have two solutions here at 10 and 0. Okay, b, I have x squared minus 4 equals 0. So two ways of approaching this one. First thing you can do, it's already all equal to 0, and you have standard form on the other side. So you can factor this if you want to. X squared minus 4 factors into x minus 2 times x plus 2. It's a difference of squares. Okay, so that gives you two answers. This one gives you x equals 2, and this one gives you x equals negative 2. Sorry, negative 2. Okay, so those are your two answers. The other way you could approach this one, again, you'll notice here with this one, x only appears once in the equation, so we should be able to solve for x as well, just without having to do any factoring. So if you're trying to look for a different way of doing this one, to solve for x, you would add 4 to both sides of the equation. So you would have x squared equals 4, and then take the square root of both sides of the equation, which would give you x equals plus or minus 2. So again, two different approaches there. Okay, both will get you the same answer. Okay, I'm going to let you guys try the rest on your own first, and then when you're ready to see the answers, push play and go through them together. Remember your general goal. If there's more x appearing more than once in the equation, okay, you try and get everything expanded over, everything over on one side, so that way you can have it equal to 0. Factor if you can and solve for the zeros. If you can't factor, the only way you can find the zeros is to put it in vertex form first, and then do what we did last example where we solved rearranged equations, solve for x. Okay, but only do that if the final equation doesn't factor. So try all of these first, and push play and ready to see the answers done as a group. Okay, so for starters, you can look at your answer for C. So what I did is I moved everything over to one side of the equal sign so I could have 0. You'll notice here I have both an x squared and an x term, so I can't just rearrange the equation to solve for x. So I put everything over on one side and wrote it in standard form. So I'd have 4x squared minus 18x plus 14. So looking at our process here, once everything's over on the same over on one side and zeros on the other side, we factor if we can and find the zeros. So 4x squared minus 18x plus 14 factors. So I take out a common factor of 2 first. So I left with 2 and then bracket 2x squared minus 9x plus 7. Then I went to factor what was inside here. So I threw it into the array, my 2x squared, my positive 7. Need two numbers that multiply to 14, add to negative 9. Those numbers will be negative 7 and negative 2. So I work out what goes on the outside, and I wind up with 2x minus 7, x minus 1. Now, a common mistake people do when they're being asked to solve an equation is once they get to factored form, they stop. They think they're done. But you're actually still not done because you haven't actually told me what x is. You haven't told me what the solution is. So you get your solution from each of the factors. So from this bracket to this factor, you get x equals 7 over 2. From this factor, you get x equals 1. And these are your two answers. Okay, so for D, if you want to check your answer, first thing, again, you'll see more than one x in the equation. I can't necessarily solve for x explicitly, so I need to follow my other strategy, which was get everything over to one side of the equal sign, 0 on the other. So I expanded through the brackets first and simplified. So I got 3x squared plus 6x when I distributed the 3x through in here. And on the right side, when I distributed the negative 1 through here, I got 2x squared minus 4 plus x. So then I took a few lines to bring everything over to one side of the equal sign. Now you may be able to do this all in one step, and if so, please do so to save yourself some time. It is possible to go straight from this step down to this step right here. So again, what I did is I brought the 2x squared over, subtracting it from both sides. I subtracted x from both sides and collected the like terms, and then moved the 4 over by adding it to both sides. So I end up with x squared plus 4x, x squared plus 5x plus 4 equals 0. Once I have standard form on one side, 0 on the other, I look to factor. So x squared plus 5x plus 4 factors into x plus 1 times x plus 4. And from each of those factors, I get my two solutions of negative 1 and negative 4. Okay? So again, you'll see a general trend. Expand, simplify, everything over to one side of the equal sign, 0 on the other side, and then try and factor. Okay, so again, if you haven't tried, well, it looks like I have two D's in a row here, but the second letter D on this page, try it right now, and check, and again, push play and ready to see your answer. Okay, so you might have noticed when you work through this last one, you may run into a potential problem. So the first thing I did is I wanted to bring everything over to one side. So I didn't show all the steps there, but I subtracted 2x squared from both sides. I added 9x to both sides and subtracted 6 from both sides and collected my like terms. So that gave me 3x squared plus 12x minus 10 equals 0. So from here, like in the other ones, I tried to factor it. When I try to put in an array, this is where I ran into a problem. I have 3x squared and minus 10, so I need two numbers that multiply to negative 30 and add to 12. You can try as long as you want, but you're not going to find those two numbers. So they don't exist, so this one unfortunately does not factor. So since it doesn't factor, in the coming days we're going to see another way of finding the x-intercepts from here. But for now, until we get to that point, the only way we can find the x-intercepts is to first put it into vertex form. Once it's in vertex form, we can do what we did a couple of examples ago, way over here, and then rearrange the equation and solve for x. So we need to put it in that form first. So there's lots of ways we've seen to go from standard form to vertex form. Two of them will work here. You can either use partial factoring and use the symmetric points to find the axis symmetry, the optimal value, the vertex, and in vertex form from there, or you could use completing the square. I personally chose completing the square, but again, if you try a different approach, you should still get the same vertex form in the end. So again, whichever one you feel is best. So I did complete the square. I didn't show all the steps. I didn't show the array, but when I factor out the 3, I get x squared plus 4x. In the array, I'd figure out if I split 4x evenly, it would have 2x and 2x, so I'd have to add 4 and subtract 4 to complete my square. I don't need the minus 4 as part of the completing the square, so I kick it out of the bracket, and it gets multiplied by the a value of 3. So I wind up with, in the end, once I'm simplified everything, 3 times bracket x plus 2 all squared minus 22 equals 0. And now if I want to solve for x, I can do so by rearranging the equation. So I added 22 to both sides of the equation, divided both sides of the equation by 3, took the square root, and then subtracted 2 to get my 2 solutions. Okay, now take some time to go through the steps, make sure you can get it to work. Even though there is a faster way coming up, it's good to know this process. You never know when you're going to be stuck, forced having to use it. But keep in mind here, there is going to be an easier way. It's just a bit of a painful process here. But right now, if something does not factor, this is the only way we have of finding the zeros. Okay, so that's it, that's all. This is a very, very important skill coming out of grade 10 to be able to solve quadratic equations. Whether you take mixed math or university math next year, you'll have to solve a lot of quadratic equations. You'll have to do it a lot in 4U as well, and a lot in any university program that's going to require math. You'll be doing it there as well. So please make sure that this is a skill that you have reinforced. Make sure you do these examples. Come in for questions as soon as you can if it's not working out, because this is a skill that needs to be really, really reinforced going forward. Okay, that's it for this one, and we'll see you later.